Assalamualaikum and good evening. My name is Muhammad Faiz Firdaus bin Muhammad Zari with matrix number B0920101257 from BMM 11. Now, here I'm going to present the assignment of pressure in pipe for subject fluid mechanics. Now, I'm going to introduce our group members for this assignment. Firstly, we have Iqmal Hakimi bin Badrul Hisham with a matrix number B0920100062. And then me, Muhammad Faiz Firdaus bin Muhammad Zahari. And then Muhammad Saiful Ikhwan bin Ismail with matrix number B0920100329. Next, we have Muhammad Amirul Aziz bin Muhammad Rizal with matrix number B0920100326. Now I'm going to explain about this introduction. So, what is fertigation? Fertigation is a method of growing vegetables that reduce the quantity of watering required. There are two sorts of pipe layout that can be used for watering: straight line and closed loop. These two alternative arrangements will result in difference in flow rate and water volume obtained by each plant. This circumstance will eventually have an impact on the plant quality.
Assalamualaikum and salam sejahtera. My name is Iqmal Hakimi bin Badrul Hisham. I am from class Bmmh section 1/1. Okay. My matric number is B0920100062. Okay. I will explain the objective of this assignment that me and my group that have done. Okay. The first objective is to perform experimental and simulation flow exercise in hose pipe. Okay, next, pressure variation in a hose pipe across a certain pipe length was investigated using two alternative arrangements. Okay, lastly, to report your findings in a professional manner. Okay, next, I will show you the equipment that we use in this assignment. Okay, first, 3/5mm diameter single connector. Okay, next 16mm T connector. Next 16mm times 10m hose pipe. Okay, next 5 or 10mm milliliter measurement cup, 10 liter measurement tank. Okay, next hose clip. Lastly, stopwatch. Okay, for the experiment setup. Okay. Experiment 1. Okay, the experiment was conducted to measure maximum flow rate and velocity from a hose pipe. 2. Then we continue to measure the maximum achievable water jet. 3. The maximum pressure was calculated in pipe based on Bernoulli equation. Okay, lastly, we assume that the system is frictionless. Okay. This is the picture that we have taken while we do this experiment. Okay, experiment setup for experiment 2A. Okay, first the hose pipe was set up in a circle shape. Okay, a single connector was used to fit minimum of 5 holes at equal distance. So we need to rearrange the hose in equal distance. Okay, take the end pipe was blocked. Okay, 4, we ensure the whole pipe on the same level. Okay, 5, we open tap up water to maximum and the flow rate with the velocity was measured at each hole in once over the same period. Okay, lastly, we recorded the data properly. Okay, this is the picture that we have taken while doing this experiment. Okay, for experiment B, the experiment setup is this. Okay, first the hose pipe was set up in a straight line. As you can see, this is the pipe. Okay, two, the T connector was used to make it a closed loop. Okay, third, we need to ensure the whole pipe is on the same level. Okay, fourth, we open the tap up to maximum and the flow rate with velocity was measured at each hole in once over the same period. Okay, lastly, we recorded the data properly. Okay, that's all from me. Thank you. I will give the next presentation uh, to my friend. Thank you.
Assalamualaikum warahmatullahi wabarakatuh, and hello to everyone. Okay, my name is Muhammad Razif Rizal, and I will continue the presentation. Okay, for the simulation and analysis, the calculation that we use or the software that we use is NC, which means the calculation for this T-type pipe and the elbow pipe, the two different type of pipe. Okay, before we use the calculation, we must set the parameter of the pipe, the material, the fluid, and the diameter and so on to describe about this pipe to calculate the all the type of calculation we need, like the velocity, density or viscosity. Okay, and this is example. Or you can see we select the water inlet, the molecular viscosity, and after we finish the compute, we can get the data. Okay, next, the data that for the simulation of T-junction pipe is the pressure, density, velocity, viscosity, and the mesh. For the inlet and the outlet, as you can see, the pressure is 299.2691.989. The outlet 0. Okay, for the pressure and all the this type of data, we must use the phase average. It means only the phase for the in and out. Okay, so for inlet is in 291.989 and the outlet 0, which means this not type for side, outlet for left and right, and inlet is from above. So this only calculate from the above, okay, not from the side by side. And the density is same. Density, as you can see, 3 and 1.5, and viscosity is same. The mesh coordinate x is this type of data, 1.331 and 1.2. Okay, for next is the L elbow type of pipe, and the same like before. The set the parameter like the material, type of liquid that flow in this pipe, and the diameter and so on for the calculate for the this type of calculation that we need. And after we compute the type of parameter, we can get the field variable like density, and we select the which type of the surface that we want. You see, inlet and outlet. Okay, it's same like a phase average. And after that, get the data, simulation data on elbow pipe, the same like the previous one, the inlet and the outlet. And the pressure, density, velocity, viscosity, and mesh is the inlet and outlet. As you can see, is from above. Is y-axis is 35850.54, and the outlet 0. That's the same like no, but side by side. There's the pressure. It's only from the up and down for y-axis only. Okay. And density is same because of water. We use the liquid as water. And the viscosity, the velocity is inlet is 6 and 4.45364 for outlet. Okay. This is the calculation for the type of pipe that we use in the figure A and figure B. The T type of pipe in the figure 2B, and the elbow pipe is for figure 2A. Okay, the viscosity and mesh coordinate is same like before. Okay, that's all from me, and I will pass to next presenter. Okay, thank you.
Assalamualaikum and greetings. My name is Saiful, and I will explain about the calculation for the experimental. So in the screen, this is the list of the variables we have collected from the previous experiment. You can see here the diameter of the pipe. The inner diameter is 16 mm. The pipe area can be calculated by using the formula of pi r square. When we get this value, the water collected, we collect 2 liters of water in the duration of 11 seconds. Also in the previous experiment, So we already managed to measure the maximum height of the water jet, which we label as H2 is 1.8 meter. Atmospheric pressure, which is PATF, also constant, we use the value. Dynamic viscosity of water at 25 degrees Celsius, symbol as micro. At 0.9 also concerns. Also this the rho also constants. Moving on the experimental calculation analysis. So in order to do any analysis, we must know first the variable of the flow rate, which we can calculate itself by dividing the volume of the fluid by time. We already know the time, and we already measure the volume of the water we gain, which is 2 liter meter square. We converted to meters square. Over 11 seconds, we got this value 1.8 meter square per second. There's some typo here. After that, we find the velocity of the moving fluid, which we divide the flow rate of the fluid over the cross-sectional area of the pipe diameter, and we calculated and found we got this value 0.904 meter per second. And for the next steps, we are using the Bernoulli equation and not the Pascal equation. Not that in this experiment there is the pipeline is not completely closed, and there's an open gap at the inlet in the outer of the pipeline, so we cannot use the Pascal equation. Instead, we are using the Bernoulli equation. So this is how the calculation is derived. And P1 is the pressure at the inlet over the rho g plus velocity of the fluid over the 2 times gravity is equal to pressure at the outlet over rho g plus the maximum height of the water jet. And we already do the calculation, and we finally found the pressure at the inlet is 118.475 kilopascal, and notice is pascal. However, as we might have seen the previous my friend explained in previous video, that the value of this pressure in the inlet might be a bit different from what we found in the simulation due to the several factors such as head loss and minor loss and a few more factors. And after we found the inlet pressure, we can now move to find the Reynolds number to find out whether the fluid is turbulent, laminar, or it is in the transition value. So by using the Reynolds number formula, rho Vd over by the viscosity of water, we already know all of the variable. Now we just calculate, and we already calculated and found the value is 16,198.404, which is more than 2,000 in value. That means the water flow is turbulent. Throughout the experiment and assignment, we found that if the water increased, the water that we fill up, the time taken for the water to fill up the jug will also decrease. This means that the water flow rate increase. If the water flow rate increase, it will take less time to fill the jug. I mean, it will take less time to get more water. And when the area of the pipe connector decrease during the experiment 1 in the straight line and the 2 the closed loop, the water flow rate decrease. In other words, the further the water travel, the further the fluid travel from the source of the fluid, in this case the inlet, the more the water flow rate will decrease. This will result in decrease in other variables such as the pressure. And this might be caused by several factors, which is the major loss, the head loss, the minor loss, resulting decrease in pressure, and effectively it will also decrease the flow rate of the fluid. In summary, using the experiment and simulation, we were able to apply the concept of Bernoulli equation and the uses of the Reynolds number. Of course, we also check the Moody chart, which is used to determine whether the fluid of the flow is laminar or turbulent. And By analyzing the fluid flow with the ANSYS software and the calculation, we were able to find out several specific variable that was hard to calculate, but by using the ANSYS software, we are able to find it and precisely, such as the mesh, the viscosity of the fluid, the velocity, the pressure, and as well as the fluid motion that was generated by the software. Overall, the experiment was success and was performed successfully. That's all from me. Thank you.